lesson we're going to look at how we pay for electricity. So, paying for electricity. And we need to recall how we work out the amount of energy used in an electrical circuit. So it'd be useful if you look at the previous lesson that talks about basic circuits. So I'm going to jump straight in where that one finished. Essentially, to work out how much energy, we need to work out the power of an electrical circuit and multiply it by the time. You could alternatively work out the power from working out the voltage times the current times the time. So that's how you could go about it. So let's imagine in the home, for instance, we have a 40-watt light bulb. So we have a light bulb. It's 40 watts, running for 5 minutes. Okay, what's the power used? I mean, if you want to give it a go, you can press pause and give that a go. I'll rush through the solution now because it's quite straightforward. The energy is going to be the power times by the time. 40 watts multiplied by 5 minutes converted into seconds, which gives us 12,000 joules. You notice here that we've already got quite a large number of joules being used for something domestically, which happens all the time, 40 watts, 5 minutes. That's barely any time. Okay, let's think about now a fire, an electric fire, which is 1 kilowatt, running for 1 hour. What's the energy that's going to be used there? If you want to press pause and give it a go yourselves, or we go straight into the answer. Energy again, the power times the time. This time 1 kilowatt is 1,000 watts, multiplied by 1 hour, which is 60 minutes, and each minute is each second, giving us 3,600. If you plug that into a calculator, you get 3,600,000 joules. Again, a very large number for something domestically that might happen straight away. 1 kilowatt fire, and you put it on for an hour to stay warm. Okay, so when you start paying for electricity, it would be silly to start paying per joule, because if we were to pay per joule, then you've got two problems. Firstly, right, the cost per joule would be incredibly small. And also, when you bill somebody for it, you know, the billing would use massive numbers of joules. Okay, so for those reasons, paying per joule just does not work. So instead, they've invented a new unit, and the new unit is called the number of kilowatt hours, and it does exactly what it says on the tin. Let me describe to you how you work out the number of kilowatt hours. Before, you would work out the energy in joules, and you would use the number of watts and the number of seconds. Now, we're going to use exactly the same equation. This time, the energy is measured in kilowatt hours. And the way that's done is that we convert the power into kilowatts, and funnily enough, we convert the time into the number of hours. So it is really straightforward. And what the companies then do is they charge you per kilowatt hour. And the usual cost of 1 kilowatt hour is about 8 pence. Let's say for the rest of this example, the rest of the video, we're running about 8 pence. That cost changes depending upon the energy prices and distribution rates and the national grid and so on. But for the meanwhile, let's just say that is the cost per kilowatt hour. Okay, let's try now working out the cost of running. Let's find out here, these are the costs of running a fire which is 3 kilowatts, and we're running it for 4 hours. Okay? What does that cost? Well, first of all, how many kilowatt hours are you using there? Well, the number of kilowatt hours is the power multiplied by the time. The power, of course, in kilowatts, and the time in hours, which is 3 kilowatts, and 4 hours, which gives us 12 kilowatt hours. Okay. The cost is giving me the number of kilowatt hours multiplied by the cost per kilowatt hour. Very straightforward. That gives us 96 pence. So to run a fire, a 3 kilowatt fire, 4 hours, 96 pence. Okay, that one seems really straightforward. Let's move along a bit, because it can get a little bit more complicated. We're going to now next look at a kettle. And the kettle requires 2 kilowatts for 3 minutes, and that's a kettle to boil. Okay, what's the cost of this one? Okay, well, let's first of all work out the number of kilowatt hours. And this is where it gets slightly more complicated, in that it's still the power times by the time, 2 kilowatts, but this time you've got 3 minutes, and in terms of hours, that is 3 over 60 minutes, giving you the number of hours. So that gives us a 10th kilowatt hours. Of course, the cost is going to be the number of kilowatt hours multiplied by 8 pence, which gives us 0.8 pennies. Quite manageable to pay for, you'd think. So just under £1 to boil the kettle. Okay, let's move the simplification up. What about a microwave? This time, a microwave is running at 750 watts for 24 minutes. What's the cost there? Well, the number of kilowatt hours is going to be, and now it gets a little bit more complicated, the power this time is 750 watts, which is 0.75 kilowatts, and multiplying that by 24 minutes, which is that number of hours. And that will give us, if I'm not mistaken, 0.3 kilowatt hours. Let me just quickly check that. Yes, 0.3. So, what's the cost? Well, it's the number of kilowatt hours multiplied by the cost per kilowatt hour, and in this case, 0.3 times 8 gives us 2.4 pennies. Okay, and another complication, what about if we're cooking the Christmas turkey? This time I'm going to say we have a 230 volt electrical cooker. It's drawing 25 amps, and it needs 3 hours in the oven to cook. Now, if you like, you can hit pause and give that a go yourself, if you want, but if not, let's work this out. Okay, number of kilowatt hours. Well, first of all, we need the power, and then we need the time. Slight complication with the power, we need to work out the voltage times the current. Remember the power equation. So this time we have, let's work out the power separately. 230 times 25, and that gives us 5,750 watts. So if we want it in terms of kilowatts, that's going to give us 5,750 divided by the 1,000 number of kilowatts. And the time was used was 3 hours. So that will give us 17.1 kilowatt hours to use. Quite a lot to cook the turkey. Let's put some brackets. So therefore the overall cost that's required is giving you the number of kilowatt hours multiplied by 8 pence. 17.1 times 8 giving us 138 pence. Good. Okay then, I've got one more problem for you this time, and it's mixed up a bit. This is a problem that has some difficulty to it. You're going to try and solve it yourselves. Let's imagine in your room you have, let's imagine a stereo that uses 200 watts. This is like a big hi-fi. It uses 200 watts. Okay, how long will it run for £1? How long will it run for if you're using £1? Okay, if you think you know, press pause and give it a go. Otherwise, let's look at the solution. Okay then, if we know that 8 pence equals 1 kilowatt hour, then I have 100 pence, £1. Divide that by 8 gives me 12.5 kilowatt hours. That's how many kilowatt hours I can pay for. I know that this kilowatt hours, the number of kilowatt hours, is the number of kilowatts multiplied by the number of hours. So therefore, the number of kilowatt hours divided by the number of kilowatts gives me the number of hours I can run it for. 12.5 is the number of kilowatts, as calculated for. Divided by that, I've only got 200 watts, which is 200 divided by the 1,000, i.e. 0.2. It gives me quite a substantial amount of time, actually. 62.5 hours is how long I could run it for. Okay, I hope that all made sense.